This presentation will focus on some key elements for filling out the different sections of the DEP PCSM spreadsheet. It is not intended to include all information or sections necessary to complete the worksheets. Example presentations will follow that demonstrate specific applications of filling out the worksheets for particular projects. It is highly recommended that all instructions be read and followed while filling out the worksheets. Also, it has been noted in some submissions that entering information into the worksheets and then later updating information may yield erroneous results. Therefore, it is recommended that the final output be checked or re-entered into a clean spreadsheet to verify accuracy. It is important to follow the spreadsheet instructions carefully. Omissions of data in any cell may result in the failure of important calculations on the current and/or subsequent worksheets. The spreadsheet is protected and formulas are not visible. It contains default calculations that may, in most cases, be overridden by the user's own calculations. If the user overrides any of the spreadsheet calculations, they should attach additional documentation explaining what was specifically overridden with justification. It should be noted that this presentation and subsequent presentations will use the most current version, 1.7, of the PCSM spreadsheet. Also, a separate PCSM spreadsheet should be used for each receiving surface water, but may also be used for individual discharge points. The project name on the general worksheet should be the same as the name provided in the NOI, but may also contain a watershed or discharge point identifier if applicable. The total project site area or watershed should match the total in the first column of the table. And the total earth disturbance should match the total for the earth disturbance column. It should be noted that if there are multiple watersheds or points of interest that are analyzed with the spreadsheet, and more than one set of PCSM worksheets are filled out, earth disturbance that change the areas within the watersheds must be recorded as the larger of the pre or post-development area analyzed on the volume worksheet. In all cases, the total earth disturbance from all points of analysis, summed up from the volume management worksheets, must equal the total earth disturbance reported in the NOI form. Remember, the PCSM spreadsheets are designed to analyze areas of earth disturbance only. When the information on the general worksheet is complete, a small site exemption box may appear. This box will appear at the bottom of the general worksheet if two criteria are met. 1, the total earth disturbance area is less than 5 acres, and 2, the area of post-construction impervious surfaces within the watershed is less than or equal to 1 acre. The volume worksheet utilizes the design standard under 25 PA Code 102.8 that applicants must manage the net change in volume for storms up to and including the 2-year 24-hour storm event when compared to pre-construction runoff volume. It may not be appropriate when designing to an approved Act 167 plan or other alternative design standard. Calculations that clearly demonstrate how volume management requirements of 25 PA Code 102.8 are met may be substituted in lieu of the volume worksheet. Remember again, this worksheet considers only the disturbed area. For a project in which there are 2 drainage areas and the earth disturbance results in a change to those drainage areas, information must be properly entered into the PCSM spreadsheet. 2 separate sets of PCSM spreadsheets will be prepared. The total earth disturbance value entered on the general worksheet will be the larger of the pre and post development areas found on the volume worksheet. The sum of the pre and post construction areas from both sets of volume worksheets will in total then be the same. The volume worksheet is filled out much in the same way as standard worksheet 4 in the old application format. Any deviation from the new format must have supporting documentation provided to support the alternative method. If a post-construction condition land cover is chosen that will require special instructions to maintain the CN value used in the post-construction table, then adequate details, notes, operation, and maintenance shall be provided in the PCSM design. In the non-structural BMP section, the user will provide the description of any non-structural BMPs, the credits gained, and provide separate supporting documentation for those credits. There is no limit on the amount of non-structural BMP volume credit where valid non-structural BMPs from the PA Stormwater BMP manual will be implemented. Any non-structural BMP shall have supporting calculations attached to the permit application that substantiate the credit. Non-structural BMPs are still considered a PCSM BMP, and adequate information must be provided. If a structural BMP is being designed as an MRC BMP, as described in DEP's alternative ENS and PCSM BMP listing, then additional material, including the MRC design summary sheet, must accompany the PCSM plan for each MRC BMP. For timeliness in reviewing the MRC designs, the Conservation District recommends supplying all supporting documentation that is summarized on the MRC design summary sheet right with that design and not just in the PCSM narrative. If a structural BMP is selected as vegetated, then permanent vegetation must be a dominant or significant component within the storage area and must include species other than grasses. Grasses can be used, but may not be the only species planted. The storage volume must be calculated based on the lowest outlet elevation, as the volume of stormwater must be stored within the BMP for infiltration and ET credits. If the design water level within the BMP at the 2-year 24-hour storm event exceeds the lowest outlet elevation, it may not be counted as storage volume. Please note that storage volume is not calculated automatically due to the number of variables involved. Supporting calculations shall be provided to substantiate the storage volume entered. When designing infiltration BMPs, keep in mind that the necessary 2 feet of separation to a limiting zone is measured from the bottom of the excavated surface or planned bottom of the enhanced, amended, or engineered soils. The information that is required to properly fill out the rate worksheet is explained in the PCSM spreadsheet instructions. The rate worksheet uses the design standard that must be used to manage the net change in peak rate for the 2, 10, 50, and 100-year 24-hour storms event. If modeling software is used or other calculations are performed and the rate worksheet is not used, then select Summary of Peak Rates only. The information from the separate analysis will be used to fill in the boxes in this table. If the rate worksheet is used to calculate peak rates, then precipitation amounts from NOAA will be entered here. The time of concentration can be calculated by checking this box, which will reveal options for filling out information related to sheet flow, shallow concentrated flow, and channel flow. Users may also have the option of selecting the Use Default box, which will automatically set the time of concentration values to 6 minutes. After all previous information is entered, runoff depth, unit peak discharge, and peak discharge rate are computed. An area-weighted CN value is computed from the values entered in the pre- and post-construction volume calculation tables. The BMPs entered on the volume worksheet are automatically populated into the peak rate mitigation table. The user must input peak inflow and outflow rates to and from each BMP for the various storm events. Calculations for each BMP must be attached to the permit application. When the inflow and outflow data from each BMP have been entered, the peak discharge rate table will populate to show the differences between pre-construction rates, post-construction rates without BMPs, and post-construction rates with BMPs. Peak rate requirements are satisfied when green text to the right of the table or red text when they are not. The water quality worksheet is calculated using much of the data entered on previous worksheets. If the automatically calculate CN, IA, runoff, and volume box is checked on the volume worksheet, the pre and post construction pollutant load tables will calculate automatically. If the characterize undetained areas box is checked, the designer will be able to define land cover types of post construction undetained areas for more accurate estimate of the pollutant load draining off site through untreated stormwater. If this option is not checked, then a general estimate of pollutant loads in untreated stormwater will automatically be calculated. While selecting this function is optional, in many cases, its use will be beneficial as the general approach can overestimate pollutant loads from undetained areas, and it is necessary to claim the pervious area undetained credit. If claiming other non-structural BMP water quality credits, enter a description of the non-structural BMP, the calculated pollutant load reductions, and attach supporting documentation to the permit application. The BMPs that were entered in the volume worksheet will be shown in the structural BMP water quality credit table. If there are BMPs that function only to improve water quality, such as inlet filters, these BMPs should be listed on the volume worksheet so they populate in the water quality credit table. Once all information has been entered and all calculations have been performed, a water quality compliance determination will be produced. And finally, once the design is complete and all requirements have been met, the designer will certify that the information provided is true, accurate, and complete by filling out this section.